Okay, so we've been talking about air pressure, and we've been talking really a little bit about air pressure. We've been talking about fluid pressure. Last week, we made our Cartesian diver, and it was a combination of water pressure and air pressure. We looked at Pascal's principle. We look at Archimedes' principle. Archimedes' principle is about buoyancy, and Pascal's principle is about pressure. So now we're going to talk a little bit more about the concept of just air pressure in the world around us. I made mention last week that air is a gas, water is a liquid, but they're both fluids. A lot of people think that only liquids are fluids, but fluids are liquids or gases, anything that flows. And so with our bottle, when we would squeeze the water in the bottle, it would increase the pressure in all directions, everywhere, which would make the water go up in our little straw of our Cartesian diver, which would lower its density, or would actually lower the amount of air and raise the density, and so it would sink. We would let go and the air pressure would fill back in. So then we ask a real simple question. I went to Wendy's, got this nice delicious orange vanilla Coke Zero. So I'll say, all right, how do I get a drink out of that? And if I ask anybody, all right, how do I get the drink from here and into my mouth? Because it's delicious. Well, it's pretty easy, Mr. Allison. You just sucked on the straw and then you suck the water or the Coke up into your mouth. And I would say, yeah, that's what we would say. It's really not quite that simple. I'm actually not sucking the Coke into my mouth. What I'm actually doing is just lowering the air pressure in the straw. What's really happening is the air outside around me is pushing the Coke up the straw and into my mouth. Just like when we squeezed our little Cartesian diver, it forced the water up into the straw, which made the air pocket smaller and then made it sink. So that sounds weird, and I'm getting picky, but it's true. I'm not actually sucking the drink up into my mouth. I'm actually lowering the air pressure in the straw, and the outside air pushes it right up into my mouth. So up the straw. And it's the air pressure that's pushing down on the Coke. So let me explain a little bit about air pressure. We're out here, and the normal air pressure at sea level at a certain temperature would be like 14.7 pounds per square inch. That means on every square inch of surface, there would be 14.7 pounds on it. Let's just, for sake of making it easy, round it to 15. I have this big tray right here, and not big tray, but like a cooking tray, and a jar in it, and then this is my hose, which is going to simulate the straw. I'm telling you that right now there is air pressure all around us because air is also a fluid. It's not a liquid, but it's a fluid. It's a gas. And because of that, we're sitting under several miles of air all the way up till we run out of atmosphere in space. And all that air is sitting right down on us. So it actually builds up quite a bit of pressure, almost 15 pounds per square inch. And it's pushing on every surface in all directions. So when I say I take this drink and I actually lower the air pressure and the outside air pushes in, I can use this device to show you what's going on. All this is a little clear hose. And this is just a regular old mason jar. I put a little piece of black copper wire just to make the hose stay straight so it wouldn't curl up like that. And then I have a tray of water. So what I'm going to do is stick my straw right up in the jar close to the top, put the jar down into the water, and then what I'm going to do is I'm going to suck through the straw. Now this is different. In my cup, the straw goes down into the liquid and I pull the liquid into my mouth. In this case, I now have a sealed system. I have a jar with no way for air to get in and out because the water is sealing it around the bottom. So if I remove the air from in here, it actually lowers the air pressure on the inside of the jar, but not the outside of the jar. So let's see what happens when I suck on the hose. As you can see, the water went straight up inside. So again, somebody would argue, well, you just sucked the water up in there. Well, there wasn't really, this jar just had air. All I actually did was remove the air from the jar, but I didn't pull the water up. The outside air pushed down on the down on the water. The outside air is pushing always at 15 pounds. When I put this up in there, I actually lowered the air pressure above it, so it pushed the water down and up into the jar. The reason it's staying up there is because I put my thumb over the straw, which means it's not letting the air in. If I remove my thumb, then the outside air can then push in the hole right back into there, and what's going to happen? The water is going to go right back down. So there it goes. It's kind of a crazy thing to think about because we always just think, well, you just suck the water up in the hole, or the drink up through the straw, or you just. But what's actually happening? It's the air pressure that makes all that possible. If you were on the moon, and I'm get rid of temperature and things like that, but if you're on the moon where there's no atmosphere, there is no air, and you try to drink something through a straw, it just wouldn't work. That would be the end of it, because you would try to suck it through, and there's no outside air to push in. It just wouldn't work. But here on Earth, where we have an atmosphere and a certain amount of pressure, that's exactly how this works. So we're going to take this concept of air pressure and continue to talk about that a little bit more this week and talk about a few other things. All right, thanks.